In this video, we will prove that divergence of curl of a vector field equal to 0. And here the vector field f is a continuous second order partial derivative. So if f is a continuous vector field with continuous second order partial derivative, then divergence of curl of f is equal to 0. So to prove this, we know that curl of a vector field equal to the cross product of the vector field with the del operator, that is del cross f. And we know del operator, it is a vector operator and it is defined by I cap partial derivative with respect to x plus j cap partial derivative with respect to y plus k cap partial derivative with respect to z. And here the vector field f equal to I cap fx plus j cap fy plus k cap fz. To find del cross f, we will take the determinant. So determinant of I cap, j cap, k cap, partial derivative with respect to x, partial derivative with respect to y, partial derivative with respect to z, then fx, fy, fz. Now let us calculate the determinant. So for I cap, for this column and this row, you leave this column and this row. So for I cap, you have partial derivative of fz with respect to y minus partial derivative of fy with respect to z. Similarly, for j cap, you leave this column and this row. So plus j cap, partial derivative of fx with respect to z minus partial derivative of fz with respect to x, the second term. And for the third term, that is for the term k cap, you leave this column and this row. So partial derivative of fy with respect to x minus partial derivative of fx with respect to y. So this is del cross f. This is the cross product of the vector field f with the del operator. Now we'll find out what will be divergence of curl of f. And we know divergence will be for a vector function, and curl of f is a here vector function. So divergence of curl of f means del dot a vector. That means del cross f. To find del cross f, you will take the dot product of the del operator. This is the del operator, I cap partial derivative with respect to x plus j cap partial derivative with respect to y plus k cap partial derivative with respect to z. And we have found out that the del cross f is equal to I cap partial derivative of fz with respect to y minus partial derivative of fy with respect to z plus j cap partial derivative of fx with respect to z minus partial derivative of fz with respect to x plus k cap partial derivative of fy with respect to x minus partial derivative of fx with respect to y. So if you take the dot product, then only you have I dot I and j dot j and k dot k, which is equal to 1. So they exist, and other dot products, that is I cap dot j cap, I cap dot k cap, they will be equal to 0. So I cap dot I cap, which is equal to 1. So if you take the partial derivative of this this function with respect to x, for j cap component, you have j cap dot j cap is equal to 1. So partial derivative of this function, that is this one, with respect to y plus k cap dot k cap is equal to 1. So partial derivative of this function with respect to z. So if you take the partial derivative of this factor or this term with respect to x, you will have second order partial derivative of fz with respect to x and y minus second order partial derivative of fy with respect to x and z plus for the second term second order partial derivative of fx with respect to y and z minus second order partial derivative of fz with respect to y and x, the second this term. And for this third term, second order partial derivative of fy with respect to z and x minus second order partial derivative of fx with respect to x and y. Since order of partial derivative does not matter, so you have this second order partial derivative with respect to z, and here with respect to x and y. Here second order partial derivative of z with respect to y and x. Since order does not matter, they will cancel. Similarly, second order partial derivative of fy with respect to x and z. So here second order partial derivative of fy with respect to z and x. So this will cancel, and this term second order partial derivative of fx with respect to y and z. Here second order partial derivative of fx with respect to x and y. So this will also cancel. So the result will be equal to 0. Hence, it is proved that divergence of curl of a vector field is equal to 0. And this identity, vector identity, is very useful in various problems in physics.